Okay, so now that we have the radius of the coin, all right, and we know what that is, now we need to figure out the volume, because we know pi r squared is going to be the area of the top of the coin, which gives you the area, and then you multiply that by the thickness of the coin, which is the height, and that'll give you the volume of the cylinder, which is the coin. So let's actually do that. Now again, you click over here on H, the top cell, all right. Oops, actually I got to get all the way up to the top. And all I need to do is say, okay, well, I know it's a formula, so I'm going to equals, and then I'm going to put in pi, which is 3.14. And again, I know some of you guys know this up to like 50 spaces, but for our level of accuracy, we only need 3.14. So that's pi. R squared is simply r times r, so it's pi times r, which is what we just calculated, the radius in centimeters, times r, so times, whoops, not equals, times r again, times height. Now, unfortunately, I didn't convert millimeters into centimeters, so I need to do that right now. So I'm going to open parenthesis, open parenthesis, times height, which is this number divided by 10, close parenthesis. And so that's pi r squared times height. And if we hit enter, that gives us that number. All right? So I'm going to now take this number and I'm going to drag it all the way down. All right, and so if you take a look, you'll notice that a couple of things. You'll notice that the volume of the coins of the silver dollars is around 2.5, 2.6. The volume of the Kennedy half dollars is about half, a little bit less, more than half. All right, you notice the volume of the Morgan silver dollars again is pretty close to the same. All right, so now what we're going to do is now we have to calculate density. All right, and so density is mass divided by volume. Again, we do the relative drag fill again for both of these. So density is going to be, the formula equals, density is mass divided by backslash volume, enter, and we're getting something close to, I think, being accurate. Okay, so I'm just going to drag this down again. Remember, you take the cell, when the cursor goes over the bottom right-hand corner, it turns into a black cross, and we drag it down. And boom, now we have density. All right, so that's how you calculate density. Now, what we're going to do is I'm going to have you guys actually look at the class averages and then take a look at your averages and see how we do. All right, but that's basically what we're going to do. That's what we've done. What I actually want to see happen here is I'm going to actually kind of compare the class averages to your personal data. All right, but that's going to be in the next video. So we've calculated weight, we've calculated volume, we've calculated density. That's what we've done so far.